Hello, calculus fans. We talked about the ratio test. There's a similar test called the root test. This theorem says that if we let L be equal to the limit as n approaches infinity of the nth root of the absolute value of a sub n, then we get these three conclusions. And if you remember, these three conclusions are exactly the same conclusions that are in the ratio test. If L is less than 1, then the series is absolutely convergent. If it's bigger than 1, then the series is divergent. And if L is equal to 1, then the test is inconclusive. Well, this looks almost exactly like the ratio test. The only difference is how we're computing L. In the ratio test, we computed the limit of the absolute value of a sub n plus 1 over a sub n. This time we're computing the limit of the nth root of the absolute value of a sub n. All right, so let's show how we can use this. Let's find all values of x so that the power series, sum of x to the 2n over n to the n, converges. This is a power series that's centered at 0, so we know that it's going to converge at least at 0. When we see that nth power in the denominator, that n to the n, that leads us to think about the root test. All right, so we're going to do the limit as n approaches infinity of the nth root of the absolute value of x to the 2n over n to the n. Now we don't need the absolute value because everything on the inside of the absolute value is positive, so we just get the limit of x squared over n. The nth roots get rid of the nth powers. Now that limit is 0 no matter what x is. And in the conclusion of the root test, if we got a limit that was less than 1, then the series was convergent. So we can say now that the power series that we started with converges on the interval from minus infinity to infinity. That is to say, it converges for all values of x. So when we started, we knew that it converged at 0. Turns out it converges everywhere. Okay, that's all for now.